Second problem number 2. Solve dou by dou x of u is equal to 4 times dou by dou y of u by the method of separation of variables where u of 0 comma y equal to 8 times e to the power of minus 3y. Now, first write down the given equation. Given that dou by dou x of u is equal to 4 times dou by dou y of u. Say this is equation number 1. And also given that initial condition u of 0 comma y equal to 8 times e to the power of minus 3y. Say this is equation number 2. Here dou by dou x of u, dou by dou y of u. That means u is a dependent variable, x and y are independent variables. Since x and y are independent variables, we assume that the trial solution be the product of two functions. One is the function of x alone and the other one is a function of y alone, as explained in the procedure. Since x is a independent variable, y is independent variable, u is a dependent variable, let us assume that let u of x comma y is equal to x of x into y of y. As explained in the previous problem, instead of f and g, we are using capital X and capital Y. Be the trial solution. Of equation 1, where x is a function of x alone and y that of y only, where capital X is a function of x alone or only and y that of y only, y only. Now substituting equation 3 in equation 1, I explained in the previous problem. So in the next problem, I will directly substitute equation 3 in equation 1 without separately writing dou by dou x of u and dou by dou y of u. So dou by dou x of u, partially differentiating on both sides with respect to x, we will get dou by dou x of x into y, since y is a constant. Dou by dou y of y, that is equal to dou by dou y of u is equal to x is constant, derivative of y is dou by dou y of y. Now substituting equation 3 in equation 1, we get in equation 1 you have dou by dou x of u, that means dou by dou x of capital X into y equal to 4 into dou by dou y of u. Therefore x is a constant, derivative of y is dou by dou y of capital Y. For simplicity, we are avoiding x of x, y of y. So therefore clearly you understood that x is a function of small x, y is a function of small y. Therefore again this can be written as dx d by dx of capital X into y is equal to 4 into capital X into d by dy of capital Y. Since x is a function of x alone, in this case partial derivative is equal to the ordinary derivative. Here also y with respect to y, so here y is a function of y alone, therefore here partial derivative is exactly equal to the ordinary derivative, as I already shown this in the previous solution. Now this can be written as x dash, this can be written as y dash. X dash y is equal to 4x into y dash. Now this can be written as x dash into y equal to 4 into x into y dash, where capital X dash is equal to d by dx of x, y dash is equal to d by dy of y. Therefore now separating the variables, separating the variables, x variables one side, y variables another side. Now x dash by 4x equal to y dash by y. Say this is equation number 4. We already used 3 equations, so therefore this is equation number 4. Since small x and small y are independent variables, therefore equation 4 can only be true if each side is equal to the same constant k. Say this constant is a k. Since small x and small y are independent variables in the given partial differential equation, so the equation 4 will be true only when each side of the equation must be equal to the same constant. Otherwise, this equation will not be true. So therefore, we are assuming that each side of this equation is equal to the same constant k. We are assuming that is k. Now x dash by 4x is equal to y dash by y equal to k. Now simplifying this, now x dash by 4x is equal to k and y dash by y is equal to k. By cross multiplication, this can be written as x dash is equal to 4kx, and this can be written as x dash minus 4kx equal to 0, and again y dash is equal to ky and y dash minus ky equal to 0. Therefore, again this can be written as capital D minus 4k into x, where capital x capital D is equal to d by dx, and y dash can be written as d by dy of y. So we assume that capital D dash is equal to d by dy. Therefore, it becomes capital D dash minus k into y equal to 0. This can be written as capital D minus 4k into x is equal to 0, where capital D equal to d by dx. Now capital D dash minus k into y equal to 0, where capital D dash is equal to d by dy. So we are assuming that d by dx is equal to capital D, d dash is equal to d by dy, as we learned in the chapter number 1, linear differential equations with constant coefficients. There we already learned capital D is equal to d by dx, capital D dash we are writing here d by dy. That means we are writing the given differential equation in the symbolic form. Therefore, to solve this, it is a homogeneous equation. Since right hand side is 0, therefore auxiliary equation is to find the complementary function. First write down the auxiliary equation. Auxiliary equation is d minus 4k equal to 0. Therefore, d is equal to 4k. D equal to 4k. Therefore, the roots are real. Therefore, complementary function is c1 e to the power of 4k x, since independent variable is small x. Now this can be written as therefore solution of the equation is ordinary differential equation is now capital X of x is equal to C1 e to the power of 4k, independent variable is small x, 4k x. Now here auxiliary equation is d dash minus k equal to 0. Therefore d dash is equal to k. This is a real root. Therefore solution of the equation, above equation, solution of the equation is y of small y is equal to C1 already we used, so we are using C2 e to the power of k. Here the independent variable is y, ky. So which is our solution for the ordinary differential equation. This is the solution. Now substituting these values in equation number 3. In equation number 3. Substituting capital X and capital Y in equation number 3, x of x into y of y. Substituting these values in equation 3, we obtain u of x comma y is equal to x of x into y of y, that is c1 e to the power of 4 kx into c2 e to the power of ky. Therefore this can be written as c1 into c2, constants we are multiplying, e to the power of 4 kx plus ky. Since bases are equal, we are adding the powers. This is the solution u of x comma y with arbitrary constants. Say this is equation number 5. Say this is equation number 5. Now in the given problem, it is given that in equation 2, u of 0 comma y is equal to 8 into e to the power of minus 3y. Therefore, so to find the values of arbitrary constants, we use this condition. So therefore, substitute x is equal to 0 in equation number 5 to use this condition. Put x equal to 0. In equation 5, we get u of 0 comma y is equal to c1 c2 into e to the power of 4 times k into 0 plus k into y. Therefore, in equation number 2, this value is given that 8 into e to the power of minus 3y. So therefore, this is 8 into e to the power of minus 3y is equal to c1 c2 into e to the power of ky. Since u of 0 comma y is equal to 8 into e to the power of minus 3y. it is given in the problem as a initial condition. U of 0 comma y at x equal to 0 is equal to 8 into e to the power of minus 3y. Therefore, on equating the corresponding coefficients on both sides, we get, so this constant C1, C2, sometimes you may assume that this product is equal to A, because C1, C2 are arbitrary constant. After multiplying this, we will get one single constant, so we may assume that this value as A. So therefore, so to avoid this one more step, so I am just using C1, C2. Therefore, C1, C2 is equal to 8 and K is equal to minus 3, equating the coefficients on both sides. Therefore, C1, C2 is equal to 8 and K is equal to minus 3. Since on equating the corresponding coefficients on both sides, therefore substituting these values in equation number 5. In equation 5, we are substituting the values of C1, C2, that is 8, and K is equal to minus 3. 4 into minus 3 into X plus into minus 3 into Y. So 4 into 3 minus 12X minus 3Y. Substituting these values in equation 5, we obtain U of x comma y is equal to C1, C2 is equal to 8 into e to the power of 4 into minus 3 into x plus k value minus 3 into y. Therefore, this is equal to 8 times e to the power of 4 into 3 minus 12x minus 3y. This is u of x comma y. This is our required solution. Our required solution for the given partial differential equation. Problem number 3. Solve 4 into dou by dou x of u plus dou by dou y of u is equal to 3 times u, and u is equal to e to the power of minus 5y when x is equal to 0 by the method of separation of variables. This is a homework. Fourth one is solve 3 times dou by dou x of u plus 2 times dou by dou y of u equal to 0 and u of x comma 0 is equal to 4 into e to the power of minus x, e to the power of minus x. 3 times dou by dou x of u plus 2 times dou by dou y of y equal to 0 and u of x comma 0 is equal to 4 into e to the power of minus x. These two are homework. Solve by yourself. Try by yourself to find the solution of these two equations by the method of separation of variables.